Let's move on to question 3. This question is in two parts. The first part says aluminium has 13 successive ionization energies. Write the equation for the third ionization energy of aluminium and include state symbols. And then the second part gives us a set of axes, and it says on the axes below, add crosses to show the 13 successive ionization energies of aluminium. They've given us the value for the first ionization energy, and it says we don't have to join the crosses. So in terms of command words, they're not the normal typical command words here, but it does tell us exactly what to do. It says write the equation, so that's what it's asking us to do in the first bit, and a bit of extra information, include state symbols. Only 1 mark for that. If you don't include the state symbols, you won't get the mark, so it's really important we look out for those little extra instructions and make sure we follow them. Second part is for 2 marks, and it says on the axes below, add crosses, so that's what it's telling us to do to show the 13 successive ionization energies. Gives us the first one, and then again another little bit of extra instruction: you do not have to join the crosses. Okay, you probably won't lose a mark if you do that, but why take the risk? So that is our command words, what it's asking us to do. What is the key information in this question? Well, if they put anything in bold, that's because it's important. So we are looking for the third ionization energy of aluminium, and what's important, I guess, on this one is we are showing the 13 successive ionization energies, and that's a clue as to what this question is about. It is about the successive ionization energies. First ionization energy is when we take away 1 electron from an atom. Second, when we take away the second electron to form a 2+ ion. So in this case, we're talking about taking away all 13 electrons from our aluminium atom. And by the time we've done all of that, we will end up with an Al13+ ion. So we're talking about successive electrons from the same atom of aluminium. Okay, so the third ionization energy means that we will be taking away a third electron, so that will give us an Al3+ ion. So that's what we're going to be making. So we must therefore be starting with an Al2+ ion, and we're taking away an electron, so we're going to make our Al3+ plus the electron. And then the only other thing to do to finish it off is to include the state symbols, and ionization energies always defined in terms of gaseous ions. So Al2+ gaseous goes to Al3+ gaseous plus E- for our 1 mark. Okay, moving on to the second bit. To do this, we need to be clear on the electronic structure of aluminium. So it's got 13 electrons, so its electronic structure will be 2 in the first shell, 8 in the second shell, and 3 in the third shell. And that gives us some clues as to how much energy is going to be needed to remove each of these electrons. Now generally, as we take away more electrons, then the ion becomes more positive, and therefore it's more difficult to remove subsequent electrons. So the general trend here is upwards. So as I go from the first ionization energy to the second ionization energy to the third ionization energy, then that trend is upwards. But then something interesting happens, because once I've taken away the third electron, I have now taken away the 3 electrons that were in the third shell. I move down into the second shell, which is that bit closer to the nucleus, so it's held on that much more tightly. So there's a big jump when we go and remove that 4th electron. We now have 8 electrons in this shell, so again the trend is upwards, but no big jumps. So that takes us 1, 2, 3, 4, 5, 6, 7, 8. And now I've got 2 left, and those 2 are in the first shell, again much closer to nucleus, so another big jump, and it goes up like that. 2 marks for this. 1 mark is for the general trend increasing as you go from ionization energy number 1 to ionization number 13, and the second mark is to clearly show those 2 big jumps between ionization numbers 3 and 4 and between 11